In this lesson, we will introduce the main switchboard and the individual panels on the switchboard. Now let's look at the group starter panels. There are 4 group starter panels in total. On the group starter panel, the motors in the engine room can be started and stopped directly. And you can see the motor current and the current cumulative operation hours on this panel. This is the power indicator. After the main switch is closed, and the bus of group starter panel has power, this power indicator will goes on. This light indicates that the corresponding device is in standby. This light shows that the motor is running. This indicates the motor is in fault state. For example, the motor breaks. The motor is overcurrent or something else. For some larger motors, if you need to heat it up, there is a switch for the space heater. The mode choice between manual and auto is whether the current motor is in standby. For example, there are 3 main cooling seawater pumps. Number 1 main cooling seawater pump is working. We would like the number 2 and number 3 main cooling seawater pumps to be in standby condition. At this time, manual position can be selected for number 1 main cooling seawater pump. The number 2 and number 3 sea pumps choose the auto position. If the power supply of number 2 and number 3 main cooling seawater pumps is normal, and the fault trip lights didn't come on, the standby light should be on. Means the current pump is in standby state. For number 2 and number 3 pumps, the pump which first chooses the auto mode should be as a first priority to start. So when number 1 main cooling seawater pump fails, low outlet pressure of sea pump was detected by pressure switch. Number 2 or number 3 standby main cooling seawater pump will automatically start. The last 2 are the start and stop buttons. The start and stop button is used to start and stop the motor in the engine room on the group starter panel. The function of these 2 buttons is exactly the same as the start and stop button on the control box next to the motor in the engine room. And the operation permissions are exactly the same. These are the main function of the group starter panel. The equipment installed in the group starter panel is mainly the equipment that allows remote control to start and stop. For example, the main cooling seawater pump, low temperature cooling freshwater pumps, high temperature cooling freshwater pumps of the main engine, main lubricating oil pump, engine room vent fans, fuel oil transfer pump, and so on. They are installed in the group starter panel. Make operation and management more convenient. The layout of the group starter panel is arranged in sections according to the bus bar. Left and right sides is symmetrical. The same is true for the equipment in the cabin. For example, there are 3 main cooling seawater pumps. One of the pumps is at the left of number 1 group starter panel. One is at the right of number 1 group starter panel. One is at the right of number 2 group starter panel. In addition, the load on each group starter panel is numbered accordingly. For example, the top left corner of the number 1 main cooling seawater pump is 1-1. Indicates that it is the first load of the first panel from the left. Correspondingly, number 2 main cooling seawater pump at first load on panel 1-2. The number is not absolute, because the number of switchboard panel per ship and the number of loads per panel are different. But the numbering rule is basically this. The front is a number of the corresponding panel, and the back is a serial number on this panel. The distribution switch on the feeder panel also has such identification. For example, the primary side switch of the main switchboard lighting transformer has a number 3-13 on it. Indicates that the switch is the 13th switch of panel 3. That's a switch. It corresponds to the load on the primary side of number 1 transformer. Let's close the switch and jump to the power station diagram. You can see that the switch is closed. The others are similar. This is the numbering rule for the switches on the switchboard. Through these rules, we can quickly locate where the power supply or switch for each device is located. In addition to the number, these parameters below the nameplate correspond to the number of wires, diameter of wire, and the rated current of the shell used for the corresponding switch. This is the emergency cutoff sign in the upper right corner of the nameplate. Through the emergency cut mark board, we can understand the meaning of emergency cut represented by different colors. This is the engine room emergency cutoff board. We can see from this board, in emergency, if some kind of emergency shutdown is triggered, then all the corresponding loads will automatically trip. For example, if the ESS-1F emergency shutdown is triggered, then all the fan power supply switches in the engine room will trip automatically. This is its main switch. Open and close through the left mouse button to operate. SQ denotes sequential starting. Indicates that it is a sequential starting board. It means when power is restored after the ship loses power. Start the loads in a chronological order. The parameter of 22S down here indicates power will be supplied 22 seconds after power is restored. The serial number of each device is different. The purpose is to avoid a big impact on the power grid caused by the simultaneous supply of all equipment after the power supply is restored to the whole ship. These devices are therefore numbered according to their priority and their importance. Power them at regular intervals. For example, SQ2 is powered ahead of SQ5. It supplies power to the main lubricating oil pump in 7 seconds after power restored, and power to the main cooling seawater pump in the 22 seconds. On the group starter panel, the function of each panel is similar. In addition to the group starter panel, there are 5 feeder panels on the main switchboard. These feeder panels redistribute power from the main grid to an electrical distribution box or load assigned to an engine room. For larger loads, they are generally distributed directly through the AC 440-volt feeder and the 220-volt feeder panel. Some of the smaller loads were fairly scattered load. It is secondary distribution through the switchboard in the engine room or the group started panel in the engine room side. For example, LSGSP means that this group starter panel is mounted on the startboard side of the bottom of the engine room to make secondary power distribution on this panel. This load only refers to the corresponding group starter panel in the cabin field. The group starter panel also manages several loads. Click the Jump tab to take a look at this panel. This group starter panel is different from the 4 group starter panels we saw earlier. They are installed in the engine room. Mainly is a cabin of some small equipment for centralized management. For example, lubricating pump, inert gas deck seal water pumps, and so on. The power inlet switch for this panel needs to be closed here. There are 2 incoming breakers here. There are number 1 bus breaker and number 2 bus breaker. The switch on the left 440-volt feeder panel just supplied power to this point. When we close this breaker, this panel is only partially powered. Check the actual ship drawings to determine exactly which equipment is powered. The number 1 bus incoming breaker controls the load on the left side. There's also an LSGSP switch on the right AC 440-volt feeder panel. This switch is in series with the number 2 bus incoming breaker in the engine room. In other words, the engine room field group starter panel is powered by 2 channels. The power supply from the left bus and the right bus respectively. This part on the left is powered by the left bus. This part on the right is powered by the right bus. This part is the distribution switchboard in the engine room. There are 7 panels in total. The distribution switchboard is a combination of switches and control devices that supply power to a group of electrical equipment. Distribution switchboard generally only supply for load of a single nature. It is mainly used for power distribution of circuits with rated current not exceeding 16 amperes. This is the introduction of the main switchboard and the individual panels on the switchboard.